Ladies and gentlemen, this is the video that accompanies section 5.3 on the Radians chapter. I'm going to look at solving trig equations. Now, nothing in this chapter is new. Everything is the same as you did when you solved trig equations using degrees, apart from we are using radians. Now, some students will change a radian problem to degrees, solve it in degrees, and then change it back again. That's okay. That takes a little bit of extra time. If you remember, when we're in the exam, time is of the essence, and we need to make sure we use it wisely. So I'm going to go through and solve them all in radians. So you can see question 1, we need to solve cos theta equals 0.76, and we want all the solutions in the range 0 to 2 pi. So the first thing we're going to do is we're going to inverse cos both sides, or arc cos both sides. So we've got theta equals cos to the minus 1 of 0.76. Put that in your calculator, making sure your calculator is working in radians, and you get 0.76748. That, of course, is our principal angle, or our principal value. The teacher might use one of the two of those two terms, and that is what goes on our cast diagram. So I'm going to put that's going to go in the first quadrant. If you remember, pi over 2 is just over 1.5. So I'm going to put the angle on this 0.70748. If you look at the ratio is 0.76, and that's positive. So I want where cos is also positive, and that's in the fourth quadrant. So again, I'm going to add another angle, is 0.70748 radians in the right quadrant. And you can see that is my second solution. So my second solution is 2 pi minus 0.70748. And therefore the two answers to three significant figures is 0.707 and 5.58. And those are my two solutions in the range 0 to 2 pi. Now the second question, we've been asked to solve 2, 5 tan 2 theta minus 8 equals 6, and again in the range 0 to 2 pi. So the first thing we're going to look at is the angle I've got in the question, and the angle I've got in the question is 2 theta. You can see the final answers for theta need to be between 0 and 2 pi. So to make sure I get enough answers, I'm going to adapt that for the angle I've got. So that's 2 theta. So you can see theta's been multiplied by 2. So when I'm finding my alternate solutions for 2 theta, I need to go up to 4 pi. And of course, 2 lots of 0 is 0. So the next thing I'm going to do is I'm going to rearrange this to get the trig function on its own. So I'm going to add 8 to both sides and then divide both sides by 5. So I'm going to get tan 2 theta equals 14 over 5. So my ratio is 14 over 5. Then I'm going to inverse tan or arctan both sides. So 2 theta equals tan to the minus 1, or arctan of 14 over 5. Put that in my calculator, again making sure you're working in radians, and you get 1.228. Of course, that again is your principal value, or your principal angle, and that's what goes on our cast diagram. So 1.228 is slightly less than 1.5. So again, it's there in the first quadrant. The ratio was positive and we were doing tan. So where else is tan positive? That's in the third quadrant. So I'm going to put another angle in that matches that. Okay, so you can see this is my second angle. So you can see the next one is going to be pi plus 1.228. And if I keep going, I go back to the first quadrant again. So that will be 2 pi plus 1.228. And again, if I keep going, I'm down in the third quadrant again. So that's 3 pi plus 1.228. If I kept going again back up to the first quadrant, that would be 4 pi plus 1.228. That is too big for the values for 2 theta. And then pop that in my calculator, so I get the values for 2 theta, and the values of 2 theta, 1.228, 4.369, 7.511, and 10.623. And then we divide everything by 2 and round to 3 significant figures. So 0.614, 2.18, 3.76 and 5.31. And you can see, therefore, I have 4 final solutions. Now, if you look at question 4, I'm going to let you do that on your. So question 3, I'm going to let you do that on your own. And when you've done it, you can have a look at the model solutions and see if you've got the right answer. Of course, you can substitute your answers back into the original equation to see if they work. Don't forget, if you have rounded, it won't quite give you a half, but it'll be close enough to see if you've got it right or not. Right, if we look at question 4 now, you can see question 4 is a quadratic, trig quadratic. And again, we look at this. One of the most common mistakes that students will make is they will divide through by sine theta. Now, if you do that, you are going to lose half of your solutions and therefore half the marks in the exam. If you have a trig quadratic, always look for factorisation. Okay, you can see with this one, I can pull out sine theta as a common factor. So I get sine theta, and inside the bracket, I get 3 sine theta plus 1, that equals 0. So to get sine theta equals 0, or sine theta equals negative a third. Well, the first one, sine theta equals 0, we should know what the solutions to that are by knowing what the sine wave looks like. So where does sine theta equal 0? Well, that's at 0, at pi, and at 2 pi. And I'm going to leave those answers exact. The other one I'm going to solve in the same way as we did before. So I'm going to inverse sine or arc sine negative a third. When I do that one, I get negative 0.3398. Now you can see, although that is the principal angle, it isn't actually one of our valid solutions. Because it's the principal angle or principal value, that is going on the cast diagram. And negative 0.3398 belongs in the fourth quadrant. It means we're going clockwise on the cast diagram. This angle, 0.3398. And the reason is, if you look at your ratio was minus a third. So where is sine negative? Sine is negative in the third and the fourth quadrant. So I'm going to match that up and to put another one in the third quadrant. This is 0.3398. And you can see these are the 2 solutions that I want for my answer. So we've got theta equals pi plus 0.3398 and 2 pi minus 0.3398. And if you work those out with a calculator, you get 3.48 as one of your solutions and 5.94 as your other. So you can see in this question we end up with 5 solutions to this question. Now look at question 5. You can see this is trig, tan, and again I'm going to let you do this one yourself, but it does factorise. So We'll take you halfway through. Tan theta minus 5 plus 1. So tan theta equals 5, or tan theta equals -1. You solve those in the range 0 to 2 pi. You are going to get 4 solutions. So again, if you stop the video and try that one on your own, then if you get 4 solutions, you've probably got it right. And remember, you can check your solutions. Now, the second thing we're going to look at again is something that we did with degrees, is using trig identities. And there are 2 identities you should know from the time when we did trig before. The first one is that tan theta is identical to sine theta over cos theta for valid values of theta. And the second one is sine squared theta plus cos squared theta is identical to 1. And we can use these when we are solving trig equations. So you can see that first one is we need to solve between 0 and 2 pi cos theta minus 1 equals 2 sine squared theta. And you can see the trig functions I've got. I've got cos and I've got sine squared. And there are very few times where if you've got a cos and a sine squared, you can solve it. So we need to change the sine squared for its equivalent. And if you take the second identity, you can rearrange that to get sine squared equals 1 minus cos squared. So we're going to replace that. So cos theta minus 1 equals 2 lots of 1 minus cos squared theta. We're going to expand the right hand side, so we get cos theta minus 1 equals 2 minus 2 cos squared theta. We're going to rearrange it. That's 2 cos squared theta plus cos theta minus 3 equals 0. And if we factorise that, you get 2 cos theta 3, 1, and those are our signs. So it does factorise. Then what we can do, so therefore cos theta equals -3 over 2, or cos theta equals 1. Now, cos theta equals -3 over 2, or -1.5, we can't solve. That has no real solutions, because you can't solve a cos if the ratio is greater than 1 or less than -1. Second one, cos theta equals 1. You should know, therefore, that theta equals 0 and 2 pi. So this question only has 2 solutions. Next one, you've got 5 sine 2 theta equals 2 tan 2 theta. Straight away you can see that the angle we're working with is 2 theta, so I'm going to change my range. And if you notice, the range is minus pi up to pi. If I put 2 theta in, you can see when I find my alternate solutions, I need to go from minus 2 pi to 2 pi. Okay. Now, if you have a little look at this one, I've got a tan and I've got a sine. So I'm going to change the tan into sine over cos. So 5 sine 2 theta with 2 lots, and then it's sine 2 theta over cos 2 theta. I'm then going to multiply both sides by cos 2 theta. So on the left hand side, we've got 5 sine 2 theta cos 2 theta equals 2 sine 2 theta. And again, some students would then divide through by sine 2 theta. Unfortunately, again, if you do that, you're going to lose half of your solutions. So we're going to bring the 2 sine 2 theta onto the left hand side. 5 sine 2 theta cos 2 theta minus 2 sine 2 theta equals 0. And we're going to bring out sine 2 theta as a common factor. So sine 2 theta 5 cos 2 theta minus 2 equals 0. Again, look at this one. You can see therefore sine 2 theta equals 0, or cos 2 theta equals 2/5. The first one, sine 2 theta equals 1, but 0. 2 theta therefore is 0, pi and 2 pi. If you divide both of those, all of those by 2, you get 0, pi over 2 and pi. Second one, cos 2 theta equals 2/5. If you then inverse cos both sides or arc cos both sides, you're going to get 2 theta equals cos to the minus 1 of 2/5. Okay. So therefore 2 theta equals 1.159. Okay, again, that is your principal angle or principal value. We're going to pop that onto the cast diagram. So that's about here, 1.159. Our ratio was positive 2/5, positive 2/5. I was doing a cos. So where else is cos positive? That's the fourth quadrant, 1.159. So that is my second solution. So that is 2 pi minus 1.159. So 2 theta equals 1.159 and 5.124. Now, if you remember, I need to go all the way to 2 pi minus 2 pi. But if you recollect, the cos graph is symmetrical around the y-axis. Therefore, when I want to put it in purple, I actually need plus or minus 1.159 and plus or minus 5.124. You then divide all of those by 2. Theta equals plus or minus 0.580 to 3 significant figures, and plus or minus 2.56 to 3 significant figures. So you can see this question actually has 7 solutions, and you need to make sure you get all 7. Now finally, if you look at the last few questions, you're going to do these on your own, but just very quickly mark up some key points. So A, tan of 2 theta equals √3. One thing that I would notice there is you've got 2 theta, not 1 theta, so you need to make sure you get all the solutions. So again, adjust your range and make sure when you use your cast diagram, you get all the values for 2 theta in the range. Second one, notice you've got cos squared theta, so that will need changing for 1 minus sine squared theta, and then make sure you check your answers. C, again, you've got cos squared, cos theta. Very careful that you don't divide through by cos theta, losing half your solutions. Get it all onto the left hand side, rearrange it, and then factorise. Pull out cos theta as a common factor. And D, you've got a cos theta and you've got a sine theta. Whenever you see that, you are going to be trying to get tan theta. So again, if you add 5 sine theta to both sides and then divide by cos theta, you'll end up with a tan theta question, which you can solve. And again, make sure you get the right amount of solutions. That's the end of the video for section 5.3.